Okay, so we've been spending a lot of time talking about linear equations, but we're going to go back to some inequalities. We talked about inequalities at the beginning of the year, where we shaded left and right and we had open and closed circles. And now we're going to look at inequalities that are lines, and we have dotted and solid lines, and we shade above or below the line. And so if you remember this inequality chart, this is where we looked at less than was open shaded left, and greater than was open shaded right, and so on. However, we're going to look at the last two columns this time. So if I have a less than symbol, then my line should be dotted, and we shade below less than the line. And if my sign is greater than, I also have a dotted line, because remember, that's not including it. And then I shade above the line, it's greater than, so above the line. And then I have the equal to symbols, and so the only thing that changes is now I have solid lines. And if it's less than or equal to, it's solid and we shade below. And greater than or equal to, it's solid and we shade above. So you should have this paper in your folder. All right. However, with all of that being said, you cannot say the line is solid or dotted or shaded above or below without solving it for y. So all of those things that I just showed you only apply if the inequality says y is and then a symbol. And so right now my inequality does not say that, so we're going to solve the inequality for y. So brick wall, box in the 3y, and then we minus 2x on both sides. So I have 3y is less than, these are not like terms, so I say 3 minus 2x. And then we divide every term by 3. So I have y is less than 1 minus 2/3 x. Okay, and I just divided. 3 divided by 3 is 1. 2 divided by 3 is just 2/3. And just like it's y equals mx plus b, this is still my slope, and this is still my y-intercept. So my slope is negative 2/3, which means I fall 2 and run 3. And my y-intercept is 0, 1. And so let's plot some points first. So I have 0, 1 right there. And then I'm going to go down from that point, 2 and right 1, 2, 3. Down 2, right 1, 2, 3. Okay, and then we can go backwards, up 2 and back 3, up 2, back 3. Okay. And if I look at this symbol, it is less than, and if I look at my chart, less than says it's a dotted line. And we still draw arrows. So my line is dotted. And we shade, since it's less than, we shade below the line. So I would take a highlighter and I'm going to shade everything below this line. And then we need to talk about solutions. So remember, solutions or anything in the shaded area. Okay, solutions are also on a solid line. So dotted lines don't count. So anything on the dotted line is not a solution. And we're going to make a note of that over here. So let's plot these points, 0, 1, which is my y-intercept, and that is not a solution because it falls on a dotted line. And then I have 2, 3, so 2, 3 is also not a solution because it is not in the shaded area. All right. One other thing that we can do is we can graph it in a calculator. And so if I go to a graph page, I'm going to get a new document. And on the graph page, if I delete the equal sign and pick a relation, I could type in, I'm going to type in the original problem. So I have 2x plus 3y is less than, and control equals will get you your inequality symbols, less than 3. Okay. If you hover over the line, you can see that it is a dotted line. And if you're really not sure what points to plot, you can press menu 5-1, and you can just scroll left and right and find some good points. So there was -3, which we plotted. It told us the y-intercept was 0, 1, and so on. But if I am solving it, I can press tab and I can type in the inequality I got. So y is less than 1 minus 2/3 x, and then enter, and it should overlap. And it does, which means I graphed it correctly. So now to number 2. Okay. Again, we got to solve for y. So we're going to box that in. We minus x on both sides. And my inequality is y is greater than or equal to 4 minus x. And that's all I need to do. So here my slope is what's in front of x, which is -1. And my y-intercept is 0, 4. And again, if I look at my symbol, I have greater than or equal to, which means I have a solid line, and I'm shaded above, I'm greater than the line. So if I were to graph this, I would start at the y-intercept, which is 0, 4. And then my slope says to fall 1, run 1. Fall 1, because remember this is really -1 over 1. So down 1, right 1. And I keep going until I run out of room. And it's a solid line, so I'm really just going to connect all the dots. And we're shading above the line. And so again, you can use your calculator to make sure that you graph it correctly. So now the solutions. Is 2, 5 a solution? Well, 2, 5 falls in the shaded area, so yes, it is in the shaded area. Okay, is 1, 2 a solution? No, because it's not in the shaded area. All right, number 3. So I have a little hint over here. What is the one rule for inequalities? And that is if you multiply or divide by a negative number, you must flip the inequality sign. So on number 3, we're going to draw a brick wall. We're going to box in -4y and minus x on both sides. So I have -4y is greater than or equal to 8 minus, I'm going to put the 1 in there, minus 1x. And then I'm going to divide every term by -4. And when we divide by a negative, we take this inequality symbol and we flip it around. So now instead of greater than, it becomes less than. So my answer here is y is less than or equal to. That divides and gives you -2. And then here 2 negatives divide and give you a positive 1/4 x. So my slope is 1/4. My y-intercept is 0, -2. And now that I'm looking at this symbol, I can say less than or equal to. Since it has the equal to, it's a solid line. And we're going to shade below the line. And again, you can use your calculator to double check. So I'm going to add a new graph page. And we delete the equal sign. And I'm going to type in the original problem. I'm going to type in x minus 4y Control equal to get my inequality symbol, greater than or equal to because that's what the original problem said, and then 8. And here we can see if we hover over the line, we have a solid line and it's shaded below, which is exactly what we said. The y-intercept is 0, -2, so it looks like we did it correctly. So I'm going to plot the point, 0, -2. My slope says I rise 1 and I run 4. So I rise 1, run 1, 2, 3, 4. It's a solid line, so I would just connect it. I need to go the other way, so down 1, back 1, 2, 3, 4, and extend your line. And then we're shading below the line. And then let's look at these points. 4, -1. That's the point on the line right here. And that is a solution because it is on a solid line. So dotted lines don't count, but solid solutions. Help you remember that. Solid solutions, dotted lines don't count. And then I have 0, 0. That is not a solution because it is not in the shaded area. Okay, we got 2 more. We're going to do the same thing. We're going to solve for y. So brick wall, box in, let's see if I can get that to not be so blurry. Box in our y. Then we're going to subtract 4x on both sides. I have -3y is less than -12 minus 4x. We're going to divide all terms by -3. So y, since we divided by a negative, that inequality sign has to flip around. Y is greater than 4. 2 negatives here make a positive 4/3 x. So my slope is 4/3. My y-intercept is 0, 4. I have greater than, so my line is dotted. And I'm going to shade above because it's greater. And again, graph it to double check your answer. So I'm going to plot the point, the y-intercept, which is 0, 4. And then my slope tells me to go up 4, 1, 2, 3, 4, right 1, 2, 3. I'm kind of off the grid here. But I could go backwards. I could go down 1, 2, 3, 4, back 1, 2, 3. So there you have 2 points that you can use. And since it's a dotted line, put some dashes through there, add some arrows. And we're shading above the line, which is up here. So now let's plot the points. -3, 0, which is this point right here. That's my x-intercept. And that is not a solution because it is on a dotted line. -5, 3 is right here. And that is a solution because it is in the shaded area. Okay. All right. Number 5, last one. Again, brick wall, box in your y. This time my y is a -3y. I'm going to minus 2x on both sides. I get -3y is greater than 3 minus 2x. I'm going to divide every term by -3. When I divide by a negative, my inequality sign flips, so I have y is less than. And you divide and you get -1. And here you divide and you get a positive 2/3 x. Let's see. My slope is 2/3. My y-intercept is 0, -1. If I look at this, I have a less than, so it's dotted. And we're shaded below the line. And I just want to show you that on the calculator, let's just practice one more time. If I'm on a graph page, I pick a relation and I want to type in the original problem, because if I solve it and I make a mistake, the original problem will still tell me what I should have. So I have 2x minus 3y is greater than 3. Remember, control equal will get you that greater than symbol. And so here, if I hover over the line, it will show me it's dotted and shaded below like I picked. So my y-intercept is 0, negative 1, and my slope tells me to go up 2 and right 1, 2, 3. So up 2, right 1, 2, 3. You can go backwards, down 2, back 1, 2, 3, down 2, back 1, 2, 3. And it's a dotted line, so make it look dotted. And we're shaded below the line. And so let's look at these points. 0, negative 1. That's my y-intercept. That is not a solution because it is on a dotted line. And then 0, 0 is not a solution because it is not in the shaded area. Okay, so now I want you to answer the summary question, which says for the inequality y is greater than 3x minus 4, is the y-intercept a solution to the inequality? Why or why not? And you can just graph that on the calculator and decide. But remember, if the y-intercept falls on a dotted lines don't count, so it's not a solution. Whereas on the front, my y-intercept falls on a solid line, so solid lines do count.